Good morning, teacher. My name is Barbara Medina Nakato, and I present my product final that is about industrial wastewater treatment at chemical perspective. And I chose this topic because I consider that water is something very important that we have to take care of and worry about. And since water is not infinite, we have to reuse what we already use. And for this, there are treatments for the wastewater, which is what I'm talking about today. And well, what is industrial wastewater? It that which result from the use of water in production process such as washing, manufacturing, cooling, among others. And these waters can contain a complex mixture of chemical, physical, and biological contaminants, depending on the type of industry. If not treated properly, they can have negative effects on the environment and the human health. And as we know, wastewater is dirty water, or as such, contaminated water, and that some contaminants stand out more than others. And the contaminants present in these waters vary depending on the industry. For example, in the textile industry, there are dyes and heavy metals such as lead and chromium. In foods, organics, matter, and oils, and in petrochemical, hydrocarbons. This diversity forces specific treatments to be applied for each type of contaminant. Well, what is the importance of this treatment? Proper treatment of industry wastewater is crucial to prevent pollution of rivers, lakes, soils, and helps preserve aquatic ecosystem by reducing toxic discharge and safeguards public health by preventing exposure to harmful substances. And additionally, many industry must comply with local and international environmental standards. Proper treatment can also allow water to be reused, reducing cost and water consumption. And for this wastewater problem, there is an industrial process for this wastewater. It consists in 3 treatments. The primary treatment is the first stage of this process. Here, large solids are removed using sieve or crates, and subsequently, the finer suspended solids are stilled in special tanks. These steps does not remove dissolved contaminants, but it's essential to avoid blockage in the following stage. And then the secondary treatment, that is in this phase, focus on the elimination of dissolved organic matters through biological process. And one of the most common methods is the activated sludge system, where microorganisms decompose organic matter. Another method is the use of trickling filters, and it is an effective stage, but it does not eliminate contaminants such as heavy metals or nutrients. And finally, there is the third treatment, and this is more complex, and is used when high quality treatment water is such. Here nutrients such as nitrogen and phosphorus heavy metals, viruses, and bacteria are eliminated. Processes such as filtration with sand or activated carbon disinfectants with chlorine or UV light and chemical precision are used. And in case my explanation was not clear, I will show you a short video that explains this process.
Cities and towns have sewerage systems in place to carry the wastewater from our homes, hotels, factories, and other establishments to a sewerage treatment plant where the wastewater is treated. It is then deemed safe to release into other water sources. The treatment of wastewater goes through different stages. Wastewater is treated to remove the physical, chemical, and biological contaminants present in it through various processes. The pre-treatment process involves the sewage being sent through grids or vertical bars that can remove large solid substances like metal cans, paper, and plastic materials. In primary treatment process, the sewage flows through the grid chamber very slowly, so that the sand, pebbles, and soil settle down at the bottom. The sewage flows into the settling tank or sedimentation tank, where the solid wastes like feces are allowed to settle down. Wastes such as soaps, oils, and grease rise to the top of the wastewater. The waste material that settles down at the bottom is called the sludge, and the floatable material is called the scum. Scum is then removed using a skimmer, and sludge is removed with a scraper every few days. The water that is left out is called the clarified water. In the secondary treatment process, biological or organic wastes are removed. It is a biological process. This is done by transferring the clarified water into an aeration tank, where air blowers bubble air, which helps the aerobic bacteria to grow and feed on the organic contaminants such as food waste, feces, and other organisms. The mixture then flows from the aeration tank into the clarifier, where activated sludge settles out by gravity. The activated sludge so produced along with the sludge produced in the primary process is transferred to the digester, where it is decomposed by anaerobic bacteria. Biogas is produced in this process, which can be used as fuel or can be used to produce electricity. The activated sludge is then left in the sand drying beds. Some quantity of water in the activated sludge evaporates and the remaining quantity drains through the sand beds. This leaves behind the remaining dried sludge, which can be used for making fertilizers or compost. In the tertiary treatment process, the leftover wastewater is treated with chlorine to remove the phosphorus compounds, nitrogen compounds, and bacteria. It is a chemical process. Chlorine tablets are added to kill the germs. This process is called chlorination. Then this water is let off into the water bodies.
Well, I hope you understood the video, the process, and well, next, as we know, there are increasingly better tools, better technologies to continue involving in the process of anything. And for example, for this topic, in the recent years, innovative technologies have emerged that improve the efficiency of the treatment. For example, membrane bioreactors combine biological process and filtration. Advanced oxidation methods and nanomaterials are also used to eliminate contaminants that are difficult to degrade. These technologies are more expensive but reduce the generation of the sludge and improve the final quality of the water. And here, as you can see briefly, is an example of the membrane bioreactor. Finally, in conclusion, I can say that industrial wastewater treatment is a key to minimize the environmental impact of productive activity. Through physical and biological and chemical process, it is possible to reduce dangerous pollutant, protect public health, and comply with environmental regulations. With the advance of technologies such as membrane bioreactor or advanced oxidation, and new opportunities are opening of up for more efficient and sustainable treatment, which is a fundamental in the work of the industrial chemist. Thank you.